And we're back, and it's COMP228 Java programming, week 2, lesson 2, part 4, right? And we were just talking about, or going through the PowerPoint presentation from the book. That's chapter 3 from the book now. We took a short break. Again, the second video that we're doing as a straight broadcast in the evening. So that's from 6:30 to 8:30 on Tuesday nights. See how this works. If it doesn't work or if people aren't watching, then what we'll do is, like I said, we'll have to change this up and go back to the traditional way. But this is just an opportunity for everybody to work a little bit remotely and do a little bit of blended learning. Okay, let's get back to this. So we talked about null and the idea of how things are not initialized, or local variables are not locally automatically initialized. And that in order for us to initialize them, we could certainly give them default values. That's one option. Or just accept the fact that they're null, right? And I kind of went through this a little bit with you. Here's something that asks. It says, compiling and executing an app with multiple classes. Well, one thing we can do if we're using the command line is use to kind of target all Java classes, so all Java classes that are part of the project. What I can use in the command line, if I was going to do a pure command line, is do javac and then star Java, which kind of targets all the Java classes in my project, right? In a particular package, if you will. Now we're using Eclipse. We don't have to worry about this. It takes care of it for us. But generally, that's how we do it. Okay, UML. This is what this, talking about class diagrams, and this will be kind of a review. You have a whole other course that talks about UML diagrams, and it kind of indicates what all these nice things mean. The top, which is the header, body, and the footer, and what all these things mean. This is what this section is all about, this UML section. And really what it is these class diagrams that summarize what our class does. So here's an example of our account class. We have this minus. What does that mean? It's a string. We have these, these little brackets here, which is almost like a greater than sign and less than sign. These brackets, there's a special name for this. And then constructor. So we're indicating this is the constructor. And then, of course, we're saying account and the name string. So the constructor is initializing the string, right? We also have a setter and a getter for the string, and these are pluses. So what do those pluses mean? So again, just a review, this would be your UML diagram for the class. And of course, it describes here in the PowerPoint what each of these things mean. The top component is the class name. Really, that's what this is. It gives us the name for the class. The middle component, again, it talks about the middle compartment contains the class's attribute name, which corresponds to the instance variable of the same name in Java, right? So going back to this, so middle component, attribute name, so all the instance variables, middle component, right? And then the bottom component gives us all of our methods, right? For the methods for them. And of course, if you notice, there's some coding here going on. So plus indicates a public operation, right? And of course, minus then would be some kind of private operation, right? Which you can have that. Also the return types, right? So again, if I have the return type of an operation by placing a colon and the return time after the parentheses fall on the operation name. So let's take a look at this. We say name and then it's of type string. Interesting how in Java, though, when we declare a variable, it's the other way around. But in the UML diagram, we put the data type after the parameter, right, in this particular case, or after what it returns. The get name actually returns a string type parameter. So the colon and then the get name says, well, it returns a string. So that's what that really means, return types. And again, we've kind of covered basic UML diagrams. So again, you might see UML diagrams when we do our, we start using some assignments. I'm going to give you some assignments. And again, next week, you'll get your first assignment. So assignment number 1, well, you'll have to do something for assignment number 1. And it'll be kind of a review of classes. So a very simple assignment that you'll get for next week, right? And it'll be worth, I believe, 10%, something like that. But you'll probably get a UML diagram attached to it to say, hey, here's what you need to do, right? So again, they're talking about some additional notes for the class account test, and our class account test, of course, is just this driver class that we're using called program, right? And we could have called this person test instead of program, but at the end of the day, it means the same thing. So when you hear a driver class, it means the class, the central class we use to test with, right? Or a central program, if you will. Now you could certainly assign this class here to a code by itself to run on its own, right? But you need some way of testing input and output for the particular class, and that's what we're using this driver class for, this program class. Okay, going back. So import declarations. Now we did it automatically, but again, we talked about import declarations earlier today. I kind of covered this part. The import declaration, unless it's part of the same package, you have to use an import declaration to explicitly name where the class is coming from in a different package. Now think about a package as a namespace, so that way what you're doing is you're actually targeting another package. Right now, in our example, we only have one package, the default package, and everything in there, person and program, are part of the same package, so that, like I said earlier, it's implicit. We don't need to use an import, because the import for the person class, well, it's in the same package, we don't have to use it. Now I could, what if I did that? If I said like import, as an example, person, right? Well, do I need to do it? Can I do person.java? Can I do person? Can I do that? And would it make sense? Well, no, right? That's one thing that I wouldn't need to do, right? And there isn't a default person. Take a look at the error that I'm getting, right? It says, quick fix, create a class Java and type in type person, create interface Java, create annotation Java, remove the unused import. I could do, that's probably the right thing to do, right? Now here's something, Java util scanner. Remember we talked about this as reverse domain spacing, right? So how would I access the Java class? If I just wanted to import, could I just go import person? You know, I mean, let me see what it does. It says, well, here's something. The import person cannot be resolved. 4 quick fixes. Remove unused import, organize imports, search repositories for person, which we don't have, right? That's one thing I could do. And fix project setup, which is probably what I would have to have done. Right? So there is no default package, so I really can't do it. Even if I wanted to, I can't import the default package and then say person. And it's implicit anyway. Now in another example, we could certainly do that if we had a different package we're importing from. And that's what this is saying here. Classes in the same package are implicitly imported and to the source code files of other classes in that package. So you don't have to do it. It's not required. Actually, you can't, right? If it's the default package. If it's another package, you could certainly include them. But again, it's like you're looking into another folder. All right, let's take a look. This is more, we talked about this around how getters and setter variables can use to validate code. And this is really an idea of a really cool diagram to kind of indicate how it would work. So I have my name instance variable, and then I have my getter, kind of two pieces of the pie here. My getter to access my my name, to get the value from my name, to read the value, and my setter to set the value. It's a nice little diagram. Again, we kind of killed this one to death with the getter and the setter stuff, right? Let's continue. Okay, here's something. So the difference between primitive types versus reference types. This is something we should probably talk about as well. So when I talk about primitive types, right, we're talking about things like Boolean, bytes, characters, char, shorts, int, long, floats, doubles. These are all the primitive types, right? Whereas if you notice, string is missing from these primitive types. I mentioned kind of string being maybe a primitive, but it's not really. It is a complex type of variable, a complex data type. Now, is it a reference type? That's a different thing, right? So if I say reference type variables in Java, well, the only reference type variables in Java that we should think about are reference types that are classes. And that's the difference between primitives and reference types. Let's go back to there. So if I go back to this thing here, it says all other types are reference type. So classes which specify the types of objects are reference types, and so are strings. Because if you think about it, strings in a lot of ways are a grouping, an array of characters, right? So that's really what a string is a complex type. It's not just one character. It's always been that way in most languages. Some languages force you to make it a complex variable, and they don't allow you to set up a string, as an example, just by saying string. You have to kind of create a new object of string. So you would say string name is equal to new string. That's what you'd have to do, where string is the class string. Now, it does that. In some older languages, they've made you do it. Here's one. Variables of type Boolean are initialized to false by default. Well, that kind of makes sense. Because variables. What are Boolean variables? Booleans are either true or false. Example would be, my name, something that's either true or false for somebody, right? Well, is employed would be for a person class. Now, a person is the class, employee might be the subclass, right? As an example, or the child of the child class, if you will, of the parent class, superclass, if you will. So let's say if the employee was inherited from the person class, it would still be a type of person, but a special type of person, employee, right? And the employee could have an additional parameter or field called isEmployed, which would be either true or false. Are you employed? Yes or not? Kind of thing. If you are, then it's true. If not, then false. And like it says here, if you wanted to initialize some kind of Boolean variable, it would initialize by default to false. One thing is that reference types, one thing to know is reference types like classes, as well as strings and other complex types, store the location of the object that you create, the string object or the class object, if you will, whatever it is, in the computer's memory. So again, we refer to these things as objects, right? So again, when we create when we initialize the instance variables, right, of these reference types, so classes, strings, and so on, they initialize to null. And that's why it's good to have an initializer to work that out, because you don't want things to be null. Sometimes it's hard to test null, and sometimes you get some false positives if you try and look and see if an object is null or not, depending on when you test it. So it's always better to initialize to another value. Here's one. Each class you declare can optionally provide a constructor. What happens when you don't provide a constructor? And I kind of asked this question earlier today. Well, you get something called the default or empty constructor that's all automatically created for you. And the empty constructor just basically puts just the exact same thing that you would create if you didn't have a constructor whatsoever. Here we actually have a constructor that takes a string that's that's going into the account. So Jane Green would be the name of the person who owns the account, and of course that's required that would have to be required in the constructor. The constructor then would require a name parameter that's of type string. Let's take a look at the example from the book. So here we are. We're making the account class again, and in the account class we have this private string that's name. And what we're doing here is, here's the constructor. And remember, the constructor has to have the same name as the class. That's the trick there. And we're basically saying that, and again, this name is referring to the instance variable name. This is definitely one way to do it, or you can use the setter. What's wrong with using the setter to right in here inside the constructor? You could do that, and many times it's simpler to do that here, since we've already defined the setter to set the name. All right, that's one. The other option is that account test, if we want to initialize the account, right? This is what this is doing. The constructor, to initialize it, we can initialize two different objects, account 1 and account 2. Both of these are objects of the account class, right? They're two different objects. So again, how would that work for us? Well, we have one person, right? Person and as lowercase person, we could make two people, right? A person 1 and a person 2, and I could ask for this information again, right? Similarly, I could create an array of people, right? So the people array, that could be an array of more than one person. Each person would be an object that sits inside of that array. So that's something else that we could do, right? A little bit more complex structure, and I think I'd like to go over something like that with you guys later on this semester as we approach more complex topics. Okay. So let's take a look again. So again, we're just declaring two of these. This is kind of academic, right? Where we've seen this kind of stuff before in C#. So nothing new. Again, we're just simply reviewing classes and objects. Again, if I was going to declare things that we're talking about here in terms of our naming and our glossary of terms, the default constructor then is the empty constructor, right? So again, this is something you'll be tested on. If a class does not define constructors, the compiler provides a default constructor with no parameters, or the empty constructor. That's also what it's called. There's no default constructor in a class that declares a constructor. That's also very important, which means that as soon as I declare a constructor, right, that has a parameter or no parameters, doesn't give me a default constructor anymore, right? So if I want to declare multiple signatures for my class, right, that has multiple types of constructors, one that has that's empty and one that has other options, then I can declare them. But I can't assume that Java will provide me with a default constructor that's empty. Won't do that once I declare a constructor. That's very key. Sometimes people make mistakes and think that there's a default constructor and they put parentheses with nothing inside of it, but they can't do it, of course, if you're asking for a parameter. All right, so let's add this into the constructor of the UML class diagram. And again, these are called angle quotes to add them in. And again, if you were to look at your keyboard to see where that exists, and I'm on a Mac, I don't see it readily. Again, there is probably a key to add that in, but on my regular keyboard, I don't see it. For you, you're going to have a special key that you can access to add in these angle quotes. I've also seen them just with the keyword constructor from a UML perspective, so you don't have to actually add in the constructor keyword with these angle quotes, but this is best practices right here. That's why they show you what to do. Okay, so we've kind of looked at the same account class UML diagram before to just explain what these things are. Again, I like them called angle quotes, a lot easier to pronounce than guillemets, right? All right, let's take a look. Floating point number. We took a look at dealing with floating point numbers and data types. Again, floating point numbers are float, whether it's float or double, replaces decimal, right? There isn't a decimal value or decimal data type in Java. You either have floats or doubles, right? 1 is 7 significant digits, right? So for the float, and 15 for double. Now it takes up twice as much memory, but the thing is, at the end of the day, we use a double when it comes to precision. So we want something very precise, like banking calculations or currency calculations. We use a double value. So it gives us 15 significant digits. It's better to have more digits than less. We can always truncate later, especially from a scientific perspective. We definitely want to use, for scientific calculations, a double would be more in line with what we want to use. And again, here's an example of how, from an accounting perspective, we want to use a double for the balance, right? And then we can use our format, printf, to format it so that it only gives us, let's say, 2 significant digits later on, which we've seen always in our last example, right? Again, here's some examples of a public deposit method. Here's a deposit method that adds a deposit amount to the account that's of type double, right? And now there's some validation here. If the deposit amount is greater than 0, then balance is equal to balance plus deposit amount. There's another way you could write this. How could you write this? And for those of you who've used C# before, and most of you have, you could say balance plus equals to deposit amount. That's the other way you could do it. That's the shortcut method to saying balance is equal to balance plus deposit amount. That's kind of a very long way of doing it, right? And of course, get balance then is a getter that allows you to return the balance that's inside the account. So that's a very good example of how you would use that. So again, one, you would have the account constructor, right, where you set things up with a name, and you also set up the this balance is equal to a balance. If the balance is greater than 0, you can't have a negative balance here. That's what this stops, right? Balance. And last is on the bottom where you have the get name, a getter for the string if you want to get the name of the account. Who owns the account? That's pretty cool. So here's the account test class, right? So this would be like our program class in Eclipse here. So our program class to test the person class. So this is the account test class. That's what they call it. The driver class again, right? And what this does is it creates 2 new objects. And then what it does is it prints out, displays the value, that's a better way of saying it, of each account on the console using this format string, right? So here's printf, and it says basically, it interpolates this, takes the account name, balance, and then, as an example, $, and then %.2f, what that does is says, give me the account balance to 2 significant digits. So let's say 1000.00 because it's currency, right? And then a \n, this %n is equivalent to \n in a regular string, right? So what this does, it goes to the next line. It does the same thing twice. That's what this thing does. All right, so very, very good. Okay, so again, it's testing the class. This inputs some information, enter the deposit amount for the account, and it allows you to input the information by using input.nextDouble. Again, so what we're doing here is we're declaring a local variable inline, right, deposit amount, and we're saying here we're going to say use the scanner object input to get the next double. So we're actually reading the next double, and we're taking that information, and what we're doing is as soon as we get the deposit amount, we're saying, hey, we're adding so much the deposit amount, this amount, to the account 1, whatever it is, balance. Now you could actually write this a little differently. So it won't just be account 1. You can do it to any account, right? And then what you want to do is, of course, what you're going to say is account1.deposit. So you're using the deposit method to deposit the amount that the user enters into the account. Then if I want to display balances, I can display balances for 1 or 2. And then, of course, I can enter a deposit amount for account 2 and do the same thing again. So I can deposit into account number 2 as well. So this is kind of a nice little program to show you how you can use getters and setters to set values of different properties of classes or instance variables. Right? Kind of neat. A nicer program would be, hey, change a value. Which account do you want to change? Here's a menu. Create a menu with your scanner, and that allows you with a while loop. We're going to cover loops a little later, but with a while loop to cover how it works. Now you guys have covered while loops, for loops, and so on. They're exactly the same pretty much in Java. Same thing with switches, switch statements. Okay, I'm not going to go over this too much. Again, I kind of said it earlier, but when you format floating point numbers, whatever comes before the F, as an example, this is the format type for the floating point number. In this particular case, what I'm showing is 2 significant digits, right? The format specifier, right? 2 digits of precision. And we're at the end. We're actually a little early. We're at 8:36, so it kind of took us, an hour and a half to do everything. Here's the default value, right, for the instance variable. And this is the complete way of writing the account class now. I have my name as an instance variable, and I have my balance. Both of them, if you notice by the minus signs, are both private instance variables. One of them is a string, type string. The other one is of type double. You have a constructor that takes 2 parameters, one of type string, one of type double, one that's named name, the other one that's balance. And then I have a bunch of public methods that are underneath here, right, in the bottom. And one of them is a deposit amount. It returns, this is a deposit that adds a deposit amount, right, to the balance. That's what this is doing, right? And get balance, actually what it does is it reads the balance from the balance instance variable. Set name sets the name variable, and get name reads the name variable. So it's again a UML diagram to describe what we're doing, right? At the top here on this particular PowerPoint slide, it says the default value for an instance variable of type double is 0.0, right? Because of course, as soon as we go into a floating point number, then what ends up happening is we get into this. We have to use a decimal point to indicate that it's of type double or float. So that's it for me in a nutshell. We've kind of covered a lot of interesting topics here. And again, this has been a really nice review of object-oriented concepts, if you will. We've covered chapter 1, 2, and 3. If I was going to go back to the outline, by the way, I posted the outline lately. So the outline is up on eCentennial. But if I was going to go back to our plan, let's take a look at our outline just for next week. And again, I might come up with a little bit of a plan for us to look at, which is more specific. Some modifications to this plan again, but we've kind of covered, you know, chapters 1, 2, and 3. My figuring is, I know it's not, doesn't really say that here, but probably by week 4, what I might do is kind of an interim test that covers chapters 1, 2, 3, 6, and 7 by week 4. And then probably what I'll do is for the midterm, I might cover chapters 8, 9, 10, and 12. So kind of break this up a little bit for you so it's not as heavy duty. I'll let you know about that next week when I come up with a little course plan for you guys of what's happening. But next week, expect that you're going to get assignment number 1. And again, the evaluation date, it says this is where you get it, right? You get assignment 1 next week, and you're gonna have it as an example by when you get this thing, week 3, it's due probably in a couple weeks, right? It'll be the same thing for assignment 2, and then assignment 3 for week 8, and then finally you're going to get assignment 4 and assignment 5 in succession for week 11 and 12 to kind of handle some of the stuff that we're talking about there, and finally assignment 6 in week 13. So there's quite a few assignments here, and if you break them down over how much they're worth, just to remind you, they're each worth different values. The first one obviously is worth 5%, and it's going to cover using Java methods, right? So that's really what we're going to cover here in assignment 1. So expect that to come next week. And then assignment 2 is all around polymorphism and inheritance in Java applications. That's what's happening with assignment 2. Again, only worth 5% of your grade. And then finally, we're going to get a little bit more heavy duty with GUI components, and again, that's going to be worth 10%. So just wanted to go over that again just to show you the assignments. I know some of you are chomping at the bit. Someone asked me, hey, you know, can I get my first assignment yet? Next week, we're going to give it to you. It's going to give you a chance to kind of ease into some of the stuff we're talking about. When we think about what chapter 6 and 7s are, right, what are we covering in 6 and 7? We're covering methods, right? And you're getting an assignment about methods, right? So how to do methods in Java and static methods and all this other stuff. Next week is a big week. This week was kind of a smaller week in terms of we only have 1 chapter that we're covering. Next we're covering 2 chapters. So it's going to be a lot more stuff that's packed into things. So we expect that both classes are going to have PowerPoint presentations that we're going to intercut with examples of code in Eclipse. So it's going to be probably a longer session. When we do this one next week, next Tuesday, expect that we're going to go right till 9. Okay. So anyways, as for that, that's it for me for this week. Next week we'll get together and do the rest. So I'm signing off, and I'll see you next Tuesday. All right. Thanks so much.